Polar area, polar area.
Polar area. We're going to look at the area enclosed by polar curves. That's enclosed, not under, as we typically have in these problems. These problems work a little differently in polar coordinates. Here's a sketch of the area we'll be finding. Here's a sketch of what the area that we'll be finding in this section looks like. The formula for polar area is different from all previous area formulas because it's not based on rectangles. Instead, polar area uses an infinite number of sectors to find the area. Remember that a sector is a hunk of a circle, a slice of pizza from the whole pizza. The area of a sector of a circle is given by A is equal to 1/2 theta r squared, where theta is in radians. Our area is given by the radical lines from theta equals alpha to theta equals beta.
All right, so instead of top minus bottom, or area under the curve is kind of like little rectangles, okay? So area for polars kind of go out like little sectors, okay? And so I think of them as like slices of pizza, or slices of pie or something like that. And so they accumulate kind of like a fan. Does anybody know like those little fans, like those little Japanese fans or something like that? And so anyway, that to me is kind of the first one. We're going to find the area bounded by the graph of 2 plus 2 sine theta. It's going to be really important to figure out what these graphs look like. Not too much today. We'll talk about a little bit today, but a lot when we start putting two graphs together. All right, but we're going to talk about this one today. What is this? It's a healthy butt. Where's the bulk? Up. Where are the cheekies? Down. All right. Looks like. All right. And so I kind of want to talk about when it touches the pole. All right. We're going to be doing that a lot. So when does it touch the pole? When r is equal to what? 0. So I'm going to set this equal to 0. We're going to be doing this often. It doesn't help us too much in this problem, but I want you to get in the habit of it. And so we subtract 2, then divide by 2, so we get sine equals what? -1. And so when does sine equal -1? At what? At 3 pi over 2. All right? And also negative pi over 2. And so it kind of goes from negative pi over 2 all the way to 3 pi over 2 when we're doing it. And the way to kind of think about it is if we substitute in 0 right here, sine of 0 is what? 0. All right? And so then we get 0 plus 2, which is 2. And so our theta is actually kind of starting there and kind of going out. Okay, that's actually how it's going to accumulate. And it's going to get back to 2 at what point in time? At 2 pi. And so what we're going to do here is we're just going to take the integral from 0 to 2 pi, and then I'd have 1/2 out front, and then I'd have my r squared right there. Okay, because the area enclosed by these polars is 1/2 integral alpha to beta of r squared. All right, so we're going to throw that in a calculator now. Make sure you're in radian mode. Okay, we got 6 pi, but what did we get before we did that? We got 18.8496. Now, what I want you to do with these things is whatever you get in your calculator, I want you to see if it's divisible by pi. All right, so Nick already did it. And so you're going to divide it by pi, and guess what you get? You get 6. So this answer is 6 pi. All right, so we're going to be putting a lot of these in terms of pi because a lot of the times they work out with pi. All right, let's do another one. All right, so now we end up having r equals 2 sine of 3 theta. R equals 2 sine of 3 theta. What kind of graph is this? First of all, we're doing one petal, by the way. What kind of graph is this?
Rose.
It's a rose. It's a rose petal. All right, and what do we know about this rose petal? Okay, or this rose has 3 petals, and how far does it go out?
2.
It goes out 2. But a lot of the times, I need to figure out when it is on the pole. And so we're going to set this equal to 0. We're going to be doing this a lot. And so we divide by 2, so we get sine of 3 theta is equal to 0. And so when is sine 0? We covered up that 3 theta, remember? So when is sine 0? At 0 and at pi. And so what do we do to solve for theta? We divide by what? 3. And so we end up getting theta is equal to 0 and theta is equal to pi over 3. And so at 0, okay, so remember this is 0, this is pi over 2, this is pi, this is 3 pi over 2. And then pi over 3 is actually kind of like this line, like that, right there. And so my first pedal is actually going to go from 0, and it's going to go back at pi over 3. Okay, and so that's my first pedal that I'm working with. And so my other pedals are actually going to kind of start going like that because we're going to have 3 of them. However, it just says find the area of how many pedals? 1 pedal. So it starts at the pole, and then it's going to finish back up at the pole in how long? At pi over 3. It's going to go from 0 to pi over 3. So they're going to accumulate kind of like that. All right, and so we can just throw it in. So now we'd have 1/2 the integral from what? 0 to pi over 3. And then my r is what? 2 sine of 3 theta, and I'm going to square it. Make sure it's the whole quantity. And then let's use our calculator. All right, and so we end up with 1.0472. And then I hope you try to divide it by pi, and what'd you get?
1/3.
You got 1/3. So this is the same thing as pi over 3. Okay? And so what if it said find the area of the entire rows? Then how much would we have? We'd have pi. No, we'd still do 0 to pi over 3, but then we'd do what to it? We'd multiply it by 3. So we take 1 pedal and then multiply it by 3. All right? Let's look at the next one. All right? So now it says find the area of 1 pedal of 4 cosine 2 theta. So what do you know? This is a rose again because it's basically telling us because it's a pedal. But what do you know about this rose? How many petals will it have? It'll have 4 petals. And how far out will it go? 4. All right? And so a lot of the times we're going to figure out when it's going to touch the pole. All right? And so let's do it. So now we're going to set this equal to 0. So we're going to set r equal to 0. So we have 0 is equal to 4 cosine of 2 theta. Divide by 4. So we get cosine of 2 theta is equal to 0. So when does cosine equal 0? At pi over 2 and at 3 pi over 2. However, have I solved for theta yet? No. What do we need to do? Divide by 2. So now theta is equal to pi over 4 and at 3 pi over 4. And so that tells me it's going to reach my pole at pi over 4 and at 3 pi over 4. And so our pedal is actually going to go kind of like that. Okay? Because it goes from pi over 4 to 3 pi over 4. Are you following that? Okay? And so now it kind of have 4 of them kind of like that. Because we know it's 4, that would make sense on that part. Are we pretty good there? All right, so because of that, I personally would just find the integral from what? We'd have 1/2 the integral from what? Pi over 4 to 3 pi over 4. Okay, so I would find the area of that pedal right there. All right, I'm going to show you different ways to tampa in a sec, though. And then my integrand would just be what? 4 cosine of 2 theta quantity squared. Jackson, what do we get? 6.2832. All right, which is actually equal to 2 pi. All right. I want to do another way to tampa because I want to show you that you can go different ways. All right. If you were to substitute in 0, a lot of the times we try to figure out where things start. If we were to substitute in 0 for theta, what would we get? We'd get 4. And so my starting point at 0, we'd be at 4. And then it goes to the pole at pi over 4, okay, just like that. And so I could find the area of that pedal, like that half of the pedal. And so then I would have like 1/2 the integral from 0 to pi over 4 of this 4 cosine of 2 theta quantity squared, d theta. However, how many of that do I want for just one petal? I want 2 of them. All right, so then I'd have 2 times 1/2 the integral from 0 to pi over 4 of that. And guess what we'd still get? We'd still get the 2 pi. All right, and so there's a lot of different ways you can do these problems. And so it kind of depends on your preference, okay, sometimes. All right, cool. Let's do another one. All right, so this one we're going to find the area inside one loop of r squared equals 4 cosine of 2 theta. So is this one that we know? No. So this is where I would tell you, if we have a calculator and they don't give you a picture, more than likely they're going to give you a picture on this one. Okay, they're going to. Or they're going to give you your calculator. So this time I would suggest going to polar mode and graphing it. We're going to figure out when it touches the pole. So we're going to set r equal to 0. So now we have 0 is equal to 4 cosine of 2 theta, just like we did prior. And so when does cosine equal 0? Pi over 2 and at 3 pi over 2. So now I have 2 theta is equal to pi over 2. And 2 theta is equal to 3 pi over 2. And so now I end up with theta equals what? Pi over 4 and at 3 pi over 4. All right. So this is the way I would do it. I kind of want to figure out where the crap this thing starts. And so I would substitute in 0. And what would I get at 0? What is my r? It's actually 2 because it's r squared. And so it's really 2, but it starts here. Like, that's really the purpose behind it. It starts there, yes? And then at pi over 4, it starts going to the pole. Are you following me on this? And so what is 0? What is 0 to pi over 4? It's how much of it? It's half of that loop. Does that make sense there? And so that's how I personally would do this problem. Okay? And so then I would say it's 2 times 1/2, because my area equation is 1/2 r squared. And so I'd have 2 times 1/2 from what? 0 to pi over 4. Of what? 4 cosine of?
2 theta squared.
No.
Quantity squared.
Why do I not square this one? Because it already is squared. Okay, it is already in the form of r squared on this limnaskid. All right, and so now we'd throw that into our calculator. And so then we end up with 2. All right, not 2 pi, but just 2. I want to tell you how most textbooks do it. I personally don't like doing it this way, but if you like it, you can do it. Most textbooks will actually find that part, and that part is actually what? It's negative. And so most textbooks will actually say the integral from negative pi over 4 to pi over 4 of this 4 cosine 2 theta. All right? And then they'll have the 1/2 out front. They'll still get 2. However, I kind of don't like to go backwards like that. I just kind of like to double that value. All right? That's personally the way I do it. All right? But is that the only way to Tampa? No. All right? If you had to figure out the entire area, you wouldn't just double it. You would actually do what? You'd quadruple it. All right? Pretty good? All right. All right, so that's our first part of our lesson for area. So your homework is worksheet 10.2, numbers 1 through 6.